Welcome to U3L8 midpoint formula. So the midpoint formula is possibly one of the most simple formulas that we're going to learn this year. And you already know a lot about midpoints, right? You know the midpoint of a segment is the point that splits it into two congruent halves. We did a lot of problems and work with midpoints in the first unit. But now what we're going to talk about is how to find the midpoint when you have x and y coordinates. So basically, you're finding the average values of the x and y coordinates. So for 2 points, x1, y1, and x2, y2, the midpoint, which is another point, xy, of the segment joining those 2 points can be found using the following formula. So to find the midpoint, you simply find the average of the x's. So you take x1, add it to x2, divide by 2. And then for the y coordinate, you do the same thing. So y1 plus y2 divided by 2. So you're just adding the 2 x coordinates, divide by 2, add the 2 y coordinates, divide by 2. So find the midpoint of the segments connecting each pair of points. Leave answers as whole numbers or simplified fractions. Perfect. So to find the midpoint of the segment connecting G to H, I'll shorten it to M for midpoint. Or you know what? For now, I'll just write midpoint out. So the midpoint is going to be the x1, which is the first x, plus x2, which is the second x. So 1 plus 5 divided by 2, comma. Then you'll do y1, which is the first y, plus y2, which is the second y. So you'll do 6 plus negative 2 divided by 2. Then what you'll have here, let me move this over a little. There we go. Then what you'll have here is 1 plus 5, which is 6 divided by 2, and 6 plus negative 2, which is 4 divided by 2. Keep simplifying and you end up with 3, comma, 2. So you end up with another coordinate that is the midpoint of the segment. Now let's look at B. Again, you can label them x1, y1, x2, y2, whatever's going to work for you. Just make sure you add the x's together and the y's together. Don't cross-contaminate, okay? So for the midpoint, you're going to add your x's. So negative 7 plus negative 3. Divide by 2, and then add the y's, 0 plus negative 14, divide by 2. We end up with negative 10 divided by 2 and negative 14 divided by 2. And of course, then we get negative 5, comma, negative 7. Okay, now let's take a look at C and D. So for C, I'm going to label x1, y1, x2, y2. For midpoint, we are going to add the x's, so 6 plus 8 divided by 2. And then for the y's, 3 plus negative 8, 3 plus negative 8 divided by 2. We end up with 14 over 2 for the x coordinate and negative 5 over 2 for the y. Now here's the thing. We will have 14 divided by 2, which is 7, and then negative 5 divided by 2, which is actually negative 2.5. So we can either leave it as a fraction, negative 5 halves, or we can write it as 7, comma, and then we can divide 5 by 2 to get negative 2.5. Either way is fine. So either of those are fine. When you're graphing it, you'll probably want to use the bottom answer, just because graphing negative 5 halves is not quite as intuitive as saying negative 2.5, right? Which is between negative 2 and negative 3. Okay, part D, x1, y1, x2, y2. So we have our midpoint as adding the 2 x's, negative 9 plus 0 over 2. Hold on, sorry. Comma, and then add the 2 y's, 1 plus negative 4 over 2. Our midpoint ends up being negative 9 halves, comma, negative 3 halves. Neither of which are going to divide to a whole number. So the only other option would be to write them as as decimals, excuse me. So negative 9 divided by 2 is negative 4.5. And then negative 3 divided by 2 is negative 1.5. So So either of those answers is fine. Again, if you're graphing, you would want this answer here at the bottom because that's going to be something that we can understand where it would be located versus having a fraction. All right, now this last question is going to be a culmination of a lot of different concepts, related concepts though, into this one problem. So I'm going to read it. I'm going to try to explain how you can break it down to figure out how to answer the question. So it says, given points M, 2, 3, and P, negative 4, 9, that are connected to create line segment MP, find the point slope form equation for the perpendicular bisector of MP. Graph both lines below. So we have two things that we have to do, really. We have to find a point slope form equation, and we have to graph both lines. So there's a couple different places you could start with this. I would say one of the probably the best places to start would be to graph M and P and connect to make that line segment so we can visually see what's happening. We already have one of the lines graphed at that point, and that I think will help us figure out where to go. So M is 2, 3, so graph that coordinate, label it M. And then P is negative 4, 9, graph that coordinate, label it P. And then use your straight edge to connect them. Okay, so there's my segment MP. You can see that that segment has a negative slope. And we've already graphed one of the lines. Now we've got to graph the other line, and we've got to make a point slope form equation for it. And this other line is going to be a perpendicular bisector of MP. So two things have to be true. First of all, it has to be perpendicular. Perpendicular means that we have opposite reciprocal slopes, right? So we're going to have to figure out the slope of the original line, and then we can find the opposite reciprocal slope so that we can make it perpendicular. Okay, we know how to do that. The other thing that has to be true is that it has to be a bisector. Well, a bisector cuts a segment in half, and it goes through the midpoint. So what we're going to have to do is find the midpoint, and we're going to use the midpoint as our x1, y1. That's going to be the point that we put into our equation because we need it to go through the midpoint. Okay, so it doesn't matter where you start. I'm going to go ahead and start with the perpendicular. Get that out of the way. So I need to find the slope of PM. So rise over run. It looks like we have to go down 1, 2, 3, 4, 5, 6. And then over 1, 2, 3, 4, 5, 6 as well. So the slope of PM. So actually, let me color code this a little bit. I want to make sure that this all makes sense. So the slope of MP is going to be negative 6 over 6, which of course is the same as just negative 1. Okay, so that means that the perpendicular slope to find the perpendicular bisector is going to be positive 1. Okay, because they're both 1 over 1, and one just has to be negative, one has to be positive. So positive 1. So that's going to be the perpendicular slope. Now for the bisector situation, we have to find the midpoint. So let me color code this as well. So to find the midpoint is going to be a totally different skill set, right? So finding the midpoint, those are not the same color, but that's okay. To find the midpoint, we need to use our midpoint formula, right? We need to add our x's, which is going to be 2 plus negative 4, divide by 2. Then add our y's, which is going to be 3 plus 9, divide by 2. We end up with negative 2 over 2, comma, 12 over 2. And so we end up with negative 1, comma, 6 as our midpoint. That's going to be our x1, y1. And we're going to go ahead and graph that just so we can make sure it looks correct on the graph. So negative 1, 6. If we graph that point for the midpoint, that does look like it's halfway between M and P. It looks like these two sides are congruent. So that looks like we did a good job on finding that midpoint. All right, now we have to finish writing our point slope form equation, okay? And then we have to graph the other line, okay? So the point slope form equation, so just to recall, if you don't remember what it is, it's y minus y1 equals m parentheses x minus x1. We now have our m, which is our perpendicular slope, okay? So we're going to use this one. And then we have x minus, and our x1 is going to be the negative 1. And then we have y minus, and our y1 is going to be 6. Okay, and then we just simplify that. So it's going to be y, hold on, let me fix this real quick. So y minus, so it's going to be y minus 6 equals, we don't really need the coefficient of 1, so we can just do parentheses, and then x double negative turns into a plus 1. So here's our equation of our line in point slope form. Now we have to graph the line in point slope form, right? So now we have to start at our midpoint. So we're going to start at this negative 1, 6, and then we're going to use our positive 1 slope here. So up 1, right 1, up 1, right 1. And then, of course, you can reverse it and go down and left, until we find all of our points. And then we can draw our line with our straight edge. Okay? And then you have your line. This is your perpendicular line, your perpendicular bisector. Okay. All right, that's it for these notes. Thanks for watching, everybody. Have a great day.